Alright, so we are doing simplifying radical expressions. Okay, so just to rehash what we have already done as far as simplifying radicals, we should be able to do something like this. If I had square root, well, I'll say 8 square root 20 times, let's put an x cubed in there, times 3 square root, let's say 12, x to the 5th, maybe? And let's throw a y cubed in there just for why not. How do we do that?
You do the tree thingy.
Okay. On the 20, so we have 4 times 5, and then 2 times 5, like that. So we can rewrite the 20 as 2 squared times 5. And then we'll do the same thing for the 12. Does anyone need to see me do it? Okay, so we have 2 squared times 3. Now what do we do?
You have to multiply the little
other things.
Yeah.
Okay.
Outside.
So the numbers in front that are not in the radical, I'll multiply, so I get 24. And then root. Now what?
You do 2 to the 4th, and then times 5x.
Times 5 times, I want the 3.
Oh, and then x to the 8th, and then y to the 3rd.
Good job. All right, now what do I do, Meredith?
And then you do 24.
I'm going to actually do the roots, so what roots can I do?
2 to the 4th.
And what other one can I do?
X to the 8th.
And I'm going to have to do something to this y cubed. What do I need to do to that y cubed, Alexis?
Make it y squared and y.
Yep. So then I can do the square root of y squared. All right, so Meredith, what's the square root of 2 to the 4th?
2 squared.
2 squared. And what's the square root of x to the 8th?
X to the 4th.
And the square root of y squared?
Y.
Then, Taylor, what's left on the radical, on the inside?
5 times 3. And y to the 4th.
Nope.
Oh, see, you confused me with that.
Yeah, we changed the y to the 3rd to y squared.
That's what I
and y.
thought. You're confusing me.
All right, so on the inside we'll have 15y, and then on the outside, this 2 squared, what is that?
2 times 2. Oh, what's the 4?
So we have 96x to the 4th y. Any questions how to do that?
No.
So we're good? Everyone's saying, hey, I basically get the idea of what I'm supposed to do there. I don't necessarily successfully do it, but I know what I'm supposed to do.
Yeah.
There's
All right.
somebody at the door.
Get out of here.
Okay, don't worry about that. All right. So today we're just going to extend this concept. We'll do the harder of the topics first. So not multiplying, because we kind of just did that. We need to be able to add and subtract these. All right, so to add and subtract them, if I have 3x plus 2x, what do I get?
5x.
5x. Ah, you had it right. Why don't I have squared here?
Because you don't add them. I forgot you multiply.
We only add our exponents if we're doing what, Reagan?
Multiplying.
We're multiplying. What if I had 3x plus 2y?
You get 5xy.
What the?
No!
What?
This is gonna be.
Ow.
Surely you guys
It would just be
realize.
No 3x plus 2y.
It would just
Thank
be
you,
that.
Austin. Explain to us, why is it just 3x plus
They're
2y?
2 different variables.
Yeah, these are not like terms. I can only combine like terms.
Well,
Holy Holy smokes, welcome to August of algebra. We cannot add those. Austin's like, yes, this is my moment of truth. I knew I learned that
It's
one.
not gonna be my last name.
Okay, so maybe we should try another one.
Oh, hey.
You leave it like that.
There you
No,
go.
you would do -4 plus 5y.
-4 what?
X squared minus plus 5y.
Anyone confused why that would be the answer? Okay.
Glad we got that covered.
Now, if we understand like terms, then adding and subtracting radicals will not be that hard. So if I have √3 plus √3, we'll treat those as if they are like terms. And what do you think you would get?
6. Let's see me 6.
Mm,
You
nice
said
try, nice try. What if I had x plus x? What would I get?
X.
What? What's x plus
2x.
x? Thank you, Dylan. 2x, right?
You said, I thought.
Okay, let's try again. If I had 4x plus x, what do I get?
4x.
What?
5X.
5x.
I don't know.
Because what's in front of this x?
Nothing.
A 1. Okay, if I have 3x plus 4x, what do I get?
7x.
Hopefully you will follow along with it. What x plus x is?
2x.
2x. √3 plus √3 is
√3.
2√3.
Wait, why is it 2
Why is it 2?
2. Why wouldn't it?
Because it's 1 in front of here and a 1 in front of here. Perhaps you'll see it better if I write it a different way.
But why don't you?
What if I had 5x plus 2x?
7x.
Okay, now follow on with this logic. Those are like terms, right? If I have 5 √3 plus 2 √3, I get 7 √3. You with me? These are like terms. Actually, the answer is the same. If I had 5 and a 4 right here, plus a 2 and a 4 right here, yes. Let's verify this. This would be 20 plus 8, right? 28. This answer is 7 times 4. What's 7 times 4? 28, right? So I can combine like terms, right? Associative property and commutative property, distributive property, that's how this is working. So if I had √3 plus √3, let's try again. What do I get?
2
2 √3 because there's a 1 right here, a 1 right here, and 1 plus 1 is 2. Are you with me now?
Yes.
Like terms, they're like terms. Now what if I had √5 plus √3?
It stay like that because
It is, yes, it is this, okay? Because those are not like, okay? What if I had 4 √5 plus 2 √5?
Be 6
6 √5. I add the number in front, okay? So now that we've gotten, I know I've written that a lot of different things. So let's kind of, what should we write down here? Let's go back to what I was trying to get us to do. √3 plus √3 is 2 √3 because they are like radicals. So these are the same. They're the same radicand in the same radical. Which means, therefore, I can add and subtract. But, notice I don't add and subtract 3. It's not √6, okay? So if I had 2 √3 plus 5 √3, I get 7 √3. And if I had 2 √5 plus 3 √3, that is 2 √5 plus 3 √3. Someone explain why that is the answer.
Because they're so not like terms.
They're not like terms, so I can't actually
So
add
your
them.
radical acts like your variable.
Right.
Okay.
It acts just like a variable. So this would be like 2x plus 3y. I can't add those. And this one up here, that's like 2x plus 5x, and that's 7x. So the radical is treated as if it were a variable. It's the same idea. I'll give you a moment to finish writing that down because we struggled through this, but we got there eventually.
You know it's Friday.
Yeah, I know. And you came in thinking I was going to show a movie. Ha! That's funny. You thought, oh, everyone's gone. He's going to be nice. No.
Yeah, we've watched movies in my first 3 classes.
Yeah.
Seriously?
Yeah, we
Oh, I
watched Tokyo
haven't.
Last
We've
Night,
been
Miss
doing
Sauter's
stuff.
2 Blocks, and then we
have.
watched Cars 3 and Mr.
We've had
Moose
work.
and we're finishing it in lab.
Okay, anyways, let's go on. That's going to bring us to the next problem. What if I had 5 root 3 plus 2 root 12? And we might say, can't do it.
You can't.
You can reduce. Can you
Yeah.
not reduce?
Yes! Yay! She said something yay. Happy. This is something happy because we saw I can simplify.
You didn't put an L?
Simplify. Okay, simplify.
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 There you go.
Root 12. Okay, so before I conclude I can't add them, I need to simplify. So I'm going to simplify the root 12. So I do that 12, 4 and 3, 2 and 2. So that's,
Why'd you reduce the 3 to a 2?
Yeah.
I'm done. There, it should have been a root 3, sorry.
Okay.
Okay, so 5 root 3, nothing I can do there. What's the square root of 2 squared?
2.
So I have 2 times 2 root 3. Do you see how I took that out?
Yep.
And so I have 5 root 3 plus 4 root 3. When I add those, 9 root 3. Okay?
Sweet.
So I simplify the radical all the way. Now I might simplify it and find I still can't add them. And that's certainly a possibility. Okay, what if I had, I'll let you get this done. Anyone lost on what we did there? No? Okay. What if I had 4 root 98 plus, let's do a minus, because we didn't do any minuses. So minus 5 root 50.
40.
You were close.
I don't know.
You were closer than me.
Okay, so we're very tempted to say, oh, I can't do that, but we need to simplify the 98. So let's prime factorize it.
2,
And
Numbers.
A number?
thank you for that astute observation. A number. Yes, we get a number. So we have 2 times 7 squared. And then we do the 50. And we get 2 times 5 squared. Any questions on how we got that? So the square root of 7 squared is 7. So 4 times 7, root 2. 5 times. Now the square root of 5 squared is 5. So we get 28 root 2 minus 25 root 2.
So it'd be 3 root 2.
3 root 2.
That's a pretty good too.
It's on steroids. It's not going to be allowed to stay in the Olympics. It's going to take its medals away from it. Okay, any questions on how I did that?
No.
Okay, so actually what we just did is the hardest thing of today's stuff.
Oh, fine.
Let's do the easiest thing of today's stuff.
It's probably accidental.
Okay? Now we need to multiply. Now we actually started class with multiply, but
That went south. It went south like it went bad.
She has not
Okay.
did anything.
Let's multiply. So this is the first case of multiply. I'm going to distribute this to both of these, right? Just like as if I had 3x plus 2y, and if I had out here a 5xy. I would distribute that to both of these and get 15 what?
X squared y
Plus,
10x y squared.
and could I combine those?
Nope.
Nope, because they are not like. Okay, so when I multiply these, here's, it's just like as if I had 2 root 3 times 6 root 6. I multiply the things on the outside, so I get 12 root 18. Now I might prime factorize that 6 if I wanted to. Do you want to or not?
No.
Nah.
Nah? Okay, so we get 12 root what?
18.
Plus 30 root,
Both.
and now we simplify the 18 and 12. So I prime factorize the 18. So I have 12 root 3 squared times 2 plus 30 root. I take that 12, I prime factorize that, 4, 2, 3. We have 2 and 3. So we have 2 squared times 3. Square root of 3 squared is?
3.
So I have 36 root 2 plus square root of 2 squared is?
2.
So I have
60.
root 3, and can I combine those?
Nope.
Nope, I'm done. Any questions how I did that?
This is a lot better than what it has been.
All right. Now we'll do the harder of the multiplication, but it's not that much harder.
Son,
We good? Well, the multiplication is easier than the adding and subtracting, but like I want to do the next thing of multiplying.
That's a lot of numbers.
Yeah. Okay. So if I had, we'll work it down here. If I had 2x plus 3y, and I was multiplying that by 5x plus 7y, how would I do that?
You distribute it
So what do I multiply first?
to 2x and the 5x.
And to get
10x.
10
Square.
x squared, then what?
2x times 7, so yeah, that would be 14xy.
And then?
3y times 5, so it'd be 15xy.
Mhm.
And then you do 3y times 7, and 20y. I mean 21y squared.
Okay, and then I would combine these two because they are like, so I get 10x squared plus 29xy plus 21y squared. So I'm going to do the same thing here. I'm going to do this times this. What do I get?
8 squared
28.
root of 28.
Okay, I'm just going to go ahead and that 14 is 7 times 2 because I like to prime factorize it first. So I'm going to get 8 root 7 times what?
2.
2
Squared.
squared.
Oh yeah.
Okay, and then to this one, I'm going to prime factorize that 6 right away. That's 2 times 3. Any questions how I'm getting that?
Wait, why'd you put a square?
Because 2 times 2 squared is,
Oh, yeah.
or 2
yeah.
times 2 is 2 squared plus,
Yeah.
or minus 24
That makes sense.
root, now I have a 3, and then I'll have 2 squared again. Do you see where I got that?
Yes.
Okay, and I wrote that too big, so I'm going to have to rewrite it. So 8 root, I'll just put the 2 in front, minus 24 root 2 squared, I'll just put the 2 squared in front, 3. I'll get my eraser here just so that this is not in the way. Oh, that's eraser fail. Okay, so now we go on. Okay, now I do the 5. So I get what?
10, 30, 32.
And we can see that 3, 7, and 2.
Oh, no, that is not-
That's 42.
Yeah.
That's not going to simplify at all. So I'll just multiply it because I don't get any squares. Do you see what I mean? And then I do the next one,
Oh,
minus 30 root. Now I will,
18. So it would
but But let's use the
3 squared times 2.
Yeah, 3 squared times 2. Do you see what I mean? Why I prime factorized it right away?
Yep.
Either way, I end up prime factorizing. I like to do it at the beginning. The square root of 2 squared is 2, so I get 16 root 7. The square root of this is, again, 2, so I get minus 48 root 3. And that does not simplify. And then the square root of 3 squared is 3, so I get minus 90 root 2. Sometimes these will be able to combine, but in this case,
That was correct.
none of them combine, so I'm done. But if I can combine them, I do. All right, that'll be actually it for today. We're going to save the division for next week, so you can put away your notes.
Yeah.